Now, good afternoon, first years. We're going to go through the homework solutions from Thursday's homework on relative frequency, and looks like my camera is behaving itself again, so we shouldn't hopefully have a repeat of only getting the notes. I think it's more useful to have them done as video lessons. In any case, let me know if there was something from Thursday's notes that you didn't understand, how one thing led to the next. Okay, let's go through the questions so that you had for homework. Question 3. Data is collected on different types of vehicles that pass through a toll bridge. I nearly said a troll bridge. And this was the results that we got. So we had different types of vehicles. We could have had a car, a van, a coach, like one of those big buses, or a lorry. And we had the frequency. The frequency just means how many of them. So there were 94 cars, 27 vans, 34 coaches, and 45 lorries. And even before I look at what the question is going to ask me, the first thing I'm going to do is add those up and work out what my total is. What's the total number of vehicles that passed through? So we have 94 plus 27 plus 34 plus 45, giving us a total of 200 vehicles. 200 vehicles in total. Now, let's look at the questions. Question A was exactly that. How many vehicles passed through the toll bridge during the hour? And the answer is 200. 200 vehicles. And that's enough showing my work here underneath that I've added them up. That's completely fine in terms of showing my work. What is the relative frequency of a car passing through the toll bridge? And write your answer as a fraction. So the relative frequency of a car is the number of cars divided by the total number of vehicles. So it's 94 out of 200, but we would simplify that. 94 over 200, giving us 47 out of 100. 47% if they'd asked for it as a percentage, but they didn't. They want it as a fraction. But whenever you're asked for a fraction, the fraction must be in its simplest form or you won't get full marks. What's the relative frequency of a van passing through the toll bridge? And this time they want us to write our answer as a decimal. So 27 divided by 200. And again, we'll put it into our calculator. 27 divided by 200. And then we'll change it to a decimal using our change button, 0.135. 0.135. They didn't say a number of decimal places, so we'll just write down everything because there's only 3 of them. What's the relative frequency of a coach passing through? And this time they want us to write our answer as a percentage. So we'll write down our probability, 34 out of 200, and then we will multiply by 100 to change that to a decimal. So we've got 34 out of 200, 34 out of 200, and we can see that's 17 out of 100, so it is 17%. We might as well just follow the process as we're used to it. 17%. 17% chance there. Okay, and that was everything for question 3. Question 4 then. The results of tennis matches played are shown in a table here. So we have 3 children. We have Mia, Alex, and Sean. And we have the number of games they won. So Mia won 4, Alex won 3, and Sean won 8. The number they lost. So Mia didn't lose any. Alex lost 1, and Sean lost 4. And then they had the total that they actually played. So Mia played 4 plus 0, Alex played 3 plus 1, and Sean played 8 plus 4. He played 12 games. What is the relative frequency of a win for each child? So the relative frequency of Mia winning will be 4 out of the 4 that she played, which is 100% or 1 if you want to write it as a fraction, or a decimal. The relative frequency of Alex winning was 3 out of the 4 that she played, or 75%, or 0.75. And the relative frequency of Sean winning, he won 8 out of 12 games, which we can leave it like that, or we can change it to a fraction in its lowest terms, 2/3, or as a percentage, it would be 66.7%. So we'd have to do some rounding there. Okay, so those are the answers there. They didn't say fraction, decimal, or percentage, so whichever format you decide to write it in is fine. The useful thing about percentages is it makes it easier to compare them. Who, according to their relative frequency, is the best player here? Who's the best player? According to their relative frequency, Mia is the best player because she won 100% of her games. But is this a reasonable way of determining who's the best player? Maybe. The thing is, Sean won more games. He won 8 games. I think I would say not really. This is only a fair way of comparing if they all play the same number of games. Because Mia might play another 8 games and lose them all, and then she would have a relative frequency lower than Sean, and we just don't know. So this is only a fair way of comparing if they all played the same number of games. That's the only way that would be fair. Okay? Now, let's move on to question 5. Saoirse puts 10 red sweets, 10 green sweets in a bag. And without looking, she picks a sweet from a bag, notes its colour, and puts it back 20 times. And we can see the results, well, you can see the results in your book. And I'm going to write down the results. I'm going to write down the total just by counting them up from the picture. So there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times she pulled out a red sweet, and 1, 2, 3, 4, 5, 6, 7 times she pulled out a green sweet. So indeed the total was 20 there. Then for part A, we're asked, what is the relative frequency of picking out a red sweet? And they want us to write that as a fraction, a decimal, and as a percentage. So 13 out of 20, we can change that to a decimal really quickly. 13 over 20, and just press our change button here, 0.65. And as a percentage, then you multiply by 100, and we get 65%. I would expect that most of you would be able to do that multiplication, that change there in your head. You just move the decimal point 2 places. What's the relative frequency for picking a green sweet? And again, they want it as a fraction, a decimal, and a percentage. So as a decimal, it's 0.35, and as a percentage, it's 35%. Why didn't I need to go to my calculator? Well, I know that these need to add up to a total of 1, no matter what I do. 1.0 or 100%. When I add these up, my total is always equal to 1 with relative frequency, because relative frequency is a probability. Now, add together the relative frequencies for picking a red sweet and a green sweet. Well, we just mentioned that, so that was part C. I'll just fill it in here. So part C was adding up our totals, and we always get 1 when we add up our relative frequencies. Okay, what is the actual probability then of picking a red sweet and a green sweet? Not the relative frequency, not the experimental probability, but the actual probability of picking a red sweet was a half, because there was 10 red sweets out of my 20 sweets, which was a half. And the probability of picking a green sweet was also 10 out of 20, which was a half, or 0.5, or 50%. So why didn't we get exactly a half? Because it's random, and you kept putting them back. So if you didn't replace them, you'd get exactly half and half. But because we kept putting them back, there was always a chance that you'd pick the same sweet out more than once. So that was an important point there. Right, let's look at question 6 then. Question 6 was a little bit more difficult. A die, a 6-sided die, was rolled 50 times, and when you roll a 6-sided die, you can get the number 1, 2, 3, 4, 5, or 6. So someone did that, and they're not telling us how many times those came up. Instead, they're telling us the relative frequency. So the relative frequency of the number 1 coming up was 0.1. So it came up 10% of the time. The number 2 came up 14% of the time. The number 3 came up 20% of the time. The number 4 came up 18% of the time. And the number 5 came up 12% of the time. So they've written it as a decimal. We know that the relative frequencies must add up to 1. So the first thing they ask us is to work out the relative frequency of rolling a 6. And we know that all of those numbers must add up to 1. So first of all, we add the other numbers. 0.1 plus 0.14 plus 0.2 plus 0.18 plus 0.12. Add up all of those, and it's fine to just use the calculator to do that work. 0.1, 0.14, 0.2, 0.18, 0.12, and we get 0.74. 0.74. And then take that from 1. Because as we saw in the last question, all your relative frequencies must add up to 1. So 1 minus 0.74 gives you 0.26. 0.26. So the relative frequency of rolling a 6, the highest actually, 26% of the time you rolled a 6. Which outcome occurred the most often? So most often, 26% of the time, was 6. Most often was 6. Which outcome, sorry guys, I did that the wrong way around. We do that again. The least often is what we were asked in part B. So which one has the smallest relative frequency? Number 1. So the least often was the number 1, and the most often, the highest relative frequency, was the number 6. Now, this one's a little bit difficult. How many times did it show the number 4? So we know the number 4, the relative frequency of number 4 was 0.18. So how many times did it come up? Okay, well, it's 18% of the time. So we're looking for 18% of how many times did we roll it? 50, because that was given in the question. That was the number of times we rolled the dice. So getting 18% of 50, it's 0.18, or 18 over 100 multiplied by 50. Remember, in maths, of means multiply. So we do 0.18 multiplied by 50, and we get 9. We get 9 times. My writing's getting worse, I'm sorry. The number 4 occurred 9 times. Which outcome is most likely to occur? rolling an even number or rolling an odd number. Okay, well, which are my even numbers? My even numbers are 2, 4, and 6. So I can add up those relative frequencies. The relative frequency of rolling an even number is going to be the relative frequency of 2 plus the relative frequency of 4 plus the relative frequency of 6, which is 0.14 plus 0.18 plus 0.26. That's just coming from the table. And that gives me, we use our calculator, 0.14 plus 0.18 plus 0.26. That gives us a total of 0.58. That's more than 50%, more than half. So therefore, we are more likely to roll an even number. I don't even need to calculate the odd ones. I can see that that's going to be bigger because it's more than half. Okay, so question 6, a little bit of a difficult question there. And I am going to ask you to do a few more difficult questions tonight before we move on from relative frequency. So that homework will be uploaded to Google Classroom today. Okay, thank you, and let me know if you have any questions.